Test. Test, test, test. Oh, okay, nice. It works. How do I set focus test? There we go. Test, test, test. Do not disturb. Oh, okay, nice. It works. How do I set focus test? Okay. Yo, can people hear me? We've had some issues with the sound last time. So if you can hear me, write something in the chat. Can you guys hear me? Voice settings, test. Test. Okay, still works. Can you hear me? Can anyone hear me? I'm just gonna wait until somebody tells me if they can hear me. People going in and out. Why is this fucked up again? I don't get it. Why is this fucked up again? I don't get it. Resolution. Why is this fucked up again? I don't get it. Resolution. Transform. Order, set color. I don't know how this works. I don't get the small little thing in the corner. Whatever. The main thing's on Discord anyways. Can anyone hear me? You're not hearing me? Ah, goddamn. How about now? Is the sound working? How is the sound working? Sound. Test. No sound. No sound. This is annoying. Input device. Test. Test. Hello. Damn. No sound. Let me know if you hear sound. Sound works on YouTube, yeah. No sound. I really don't know what to do here. I'm gonna go out and back in, stay inside, disconnect quietly, just connect. Okay, how's the sound? Sound work now? Damn, okay. Yeah, this is a weird thing with Discord. Every time I enter any stage, the first time, sound doesn't work. I have to disconnect and then reconnect and then the sound works. Damn, okay. I actually like Discord, but sometimes it's not. Sometimes it has some edge cases where it fucks up. Cool. Yeah, so today we continue. It's literally just me doing some shenanigans. I'm trying to code up a DLC oracle. DLC stands for discrete log contract, and an oracle is the one that attests to any outside events. And last time, or yesterday, I kind of, just tried to wrap my head around all these things. I was looking at the spec a lot. But basically an oracle is a very simple thing. An oracle has a key pair. So an oracle has a private and a public key, which it signs stuff for with. And then an oracle attests to events. If we look at this, an event just has an ID, it can be anything, and an event can have different outcomes. I'm at the moment coding a very simple oracle. It's just enumerated events. There's ways to do different types of events, but mine is just an enumeration of different events. And every event has different outcomes. And then the outcomes is what the oracle then signs for. And these outcomes is what people then can bet on. So with DLCs, you can build these contracts between two or more parties that pay out specific things depending on what the oracle said that happened. The nice thing about this is that the oracle is not aware of these parties entering into these contracts. It just puts the announcements out there and then attests to what happens a little bit later, and then the outcomes, and then the participants use these attestations to settle their contracts. And yeah, an outcome is literally just a string of what happened, and then you sign this string with these ephemeral keys or these secret nonces, but you commit to them beforehand to this thing called the adapter point, which then the contract people who are part of the contract can use to create these very specific types of transactions. And then as soon as you sign for one of these outcomes, they can use that signature to kind of decrypt the contract and then post the transaction on chain to settle it. So yeah, an outcome just has these things. An oracle kind of manages these events. An oracle has a key pair. And yeah, so last time I just, was struggling through this, trying to figure out what to do. My plan for today, so yesterday we did like private and public key. We can sign a message with the private key. And then we did nonces and events, which is like these outcomes. So these are the nonces and these are the events. We haven't implemented signing of these events yet. So signing would mean taking this label and signing it with this secret nonce, which is this key, this thing over here. But for this, we need to kind of follow the spec, and like this string has to be encoded in a very specific way. So when you sign something, you always sign a hash of something, and to get a hash, you need to hash some data that is in some binary format. So in order to get this string to be deterministic and always similar for any oracle, so that it's compatible with each other, there's this very specific very specific way of serializing this string, and then hashing and then signing it with a secret nonce. But I think today I just wanted to start actually making this kind of a tool that you can play around with. So adding like command line arguments, like a command line, some command line commands that you can run. And for that we're going to use clap. Clap Rust is a way to do to parse like command line stuff. And then there's this. Then we can like do stuff with this. We can test that. And then once we have that, then I'll work my way back to signing events and announcement and attestations. But I think this is more fun for today. Yeah. But yeah, this is And then after that, we're gonna do like you can configure more options. Of course, we need to like think about persistence, like database stuff. And then the fun part is then I want to connect Bitcoin, and I want this oracle to attest to different Bitcoin events. So use Bitcoin as the source of events, and then attest to these Bitcoin internal events. Most oracles use like price feeds, like what's the price of USD to Bitcoin. But I think it's kind of boring. I kind of want to do do Bitcoin stuff, like attest to weird Bitcoin things. And then people can bet on things, like people could bet on the hash, the block hash, and then bet on if it's even or odd. You can build like a coin flip game with this. Or you could attest to the fee rate market and build like fee rate stuff with this. And yeah, that's what we need Bitcoin for. So kind of as this source of events. And then we, of course, need to wrap this up into a HTTP server, add some TLS, and then make it actually run. And then when it runs, it looks similar to what we have over here. So Oracle Lava.xyz, it's a company that does like Bitcoin loans. They also have an Oracle implementation, and they always, as you can see, they always attest and announce like this BTC USD pair. And then this announcement is like a specific serialization format. It's a shame we can't look into this, but yeah, this is gonna how it's look. So then you have like, you announce things first, and then once the event has come, you get these attestations. And then these contain the basically the decryption key. I'm just going to use that word so that any people who have a contract running can then settle that contract according to whatever this attestation, whichever outcome this attestation attests to. But yeah, that's the plan. So let's have a look at the cargo toml. That's where we start. We're gonna need clap. I'm gonna make this full screen. Cargo add clap. And I'm always lazy. So I've already worked with clap before. I could like, you know, look at the fucking documentation now and figure everything out from scratch. But we use clap extensively in Ord. So I'm just gonna go to Ord and see what we did there. And then copy some stuff over. So Ord, the kind of entry point for all of this is called arguments. And I think I'm just going to create the same kind of structure there. So now we're kind of creating a command line tool so that you can do like, so this thing is called Pythia. So you could do like Pythia run, or you could do Pythia sign, and then you can like add a message to sign. And this is not kind of core of the Oracle, but I need some kind of tool to play around with so that I can test things. And yeah, so I want to start with that. It's just, you know, I need to get a feeling for this. So we can get rid of this for now. We can get rid of this. We don't need to look at this. We don't really need to look at this. I am going to edit source arguments. I'm just going to copy all of this and then remove things that I don't need. First we need to add this to the source tree. Mod arguments. Oh, can't find. Let's see, source lib clap. We need this here. Okay. Cannot find parser. It's here. Mother in Christ. So arguments run. Yeah, we don't need all of this. I think we're just gonna create. This is very complex what we did in Ord. It's gonna be a result. Yeah, we're not going to do any environmental variable parsing for now. We know that we just have, do we have some options? Do we need options? I think for now we just remove this. And then we just remove this, and then we do subcommand run. So then we also create a subcommand. Subcommand, let's see what we did here. Edit source subcommand nurse. I already have two subcommands I want to split. Oh yeah, I have my keyboard. If it's too loud, I can think about putting the sensitivity down. Let me know. It's good ASMR, okay. I didn't know it was so loud. Yeah. So yeah, I'm just, we're gonna import stuff from the main. I'm gonna add this to the module tree as well. Subcommand, and then I want two subcommands. I already know that I want to have, I think for now we don't have to create modules. We're just gonna not create too much indirection. I'm gonna create 2 of these subcommands. One is gonna be called run, and the other one is gonna be called sign. Run the Oracle server is going to just be run the Oracle, whatever. And then this is going to be not going to be sing, it's going to be sign. It's going to be sign a message with the Oracle pub key, public key. So we're gonna have these 2. Where does the fucking parser thing come from? Why is this complaining? Parser. Let's see. Is this still a type in here? Parser trait. Deriving requires the derive feature flag. Ha! It's always good to read the docs. So now I need clap and I need a feature. So I'm going to put the version here. Version. And then I'm going to add a features. Call it derive. So yeah, we want to use derive. Spaces. Yeah, and now we got rid of these things. Can I find subcommand in the scope? That's fine. We have an enum. Subcommand. How does arguments find the subcommand? I don't understand. Oh, maybe like this. Subcommand. Yeah, for now I'm just going to import everything in lib. Some people like to, I'm going to import most of it in lib, and then I'll think about method run not found in this enum. Cool. So now we implement run. So we just do this, and we're just going to return our results. Make this very simple. We'll think about more custom result types later. Self.run self.sign. I'm gonna have to add a struct later. For now, I'm just gonna do to-do. I love the to-do macro. It's great. It makes it compile. We don't have any settings for now. We're gonna implement this fucking settings thing later. Method and run is never used, but it is used. Method in this implementation. Oh, yeah, okay, so it's transitive. And now we're actually gonna run this properly. So we have our, so I'm just gonna be very lazy. And when we run this, I'm just gonna copy this over to run. This really just, you know, uses all these things. Like run just right now is just for, like, this is not a proper command. when we actually implement this, is going to be probably going to be called server, and then it runs the HTTP server, which runs the Oracle. But for now, I'm just going to print out some stuff for myself, and then we can get rid of this. And we have main, and then we just use the same thing we used down here. Yeah, we're not going to implement Control C. We're going to do arguments parse. And we're going to do args.run. And then we're going to, of course, arguments. Probably don't need the arg group for now. This is for later. Okay. Let's see. So yeah, I think this is good for now. Let's try to run this. So we're going to do cargo run, because that's the command. And there we go. So yeah, all this does is start an Oracle. So I wasn't sure, like most of the time, so the X-only public key is like a nice, it's basically the pub key that everyone uses and what all the announcements uses. It's like a compressed public key. Or it's an X-only public key, and the actual public key up here is, I think, a compressed one. And then there's also an uncompressed format, which is 64 bytes. Then, yeah, I just created an Oracle sign message, which will like move, the sign message thing will move into the sign command. And then I'm just printing out, I create like these dummy events. Like it's an event called even or odd and has two outcomes. Either the number is even or the number is odd. So I'm going to add some, randomness and then attest to whatever. If the event is even, I'm going to attest to that. And if the number is odd, I'll attest to that. And yeah, you have the secret nonce, which you shouldn't, publish like this, but I'm printing this out for myself. And then you have the adapter point, and the adapter point is the important thing. I think the spec calls this the Oracle nonce, but cryptographically this is the adapter point, and I wanted to use this word because it seemed clearer to me. It's what you use to encrypt your signature when you create these contract execution transactions. And of course, this is just a hex. So this the adapter point is a public key on an elliptic curve, which is generated from the secret nonce. So this could also, instead of adapter point, it could also be called public nonce, or Oracle point, or Oracle nonce. But yeah, I can change all of that. So cool. So now we have like very simple subcommands. I'm going to now implement the sign one. So we have run, which just does these things. So now for sign, what are we doing here? So sign should probably take an argument. So for that, I'm going to create now a directory, make dir -p source subcommand, and then I'm going to create a source subcommand sign.rs. I have to add this to the mod sign. So we got a first thing in here. I'm going to use super, so we get all the imports. And I'm also going to just copy out whatever we did here. Just so I have already something to work with. It's going to be called sign. And this is just going to be called message, which is just going to be a string. We don't need any of this. Message to sign. this is going to be called sign. It's just going to be a result. And we don't need these settings. Okay. I'm going to sit down. Okay. So we have this sign command. Now we actually have to use it. So this is now an enum that has this thing in here. And then this is just going to be a sign. And then this is going to be sign.run. And then instead of signing the message here, I'm going to move this in here. Yeah, this is all very, very dirty. But yeah, I'm just going to print. What am I going to print? I'm going to print the message, which is just going to be something, and then signature, and maybe also the public key. Although can you? Yeah, I'm just also going to print the public key. Oracle dot. Okay, so now I have to create an oracle. But oracle new, and then it's just going to be oracle dot pub key. Yeah, should be fine. We can refine the output of this and make this a struct or something and make this JSON later. So we create this. The message is just going to be self.message, public key, and then the signature is just going to be Oracle sign. Self.message as bytes. Very dirty, but so now I'm going to do cargo run sign, and this is going to be like, hey, you need to pass in a message, and the message is going to be my name is Pythia. So we got the message, we got a public key, and we got a signature. Why not? I think first of all, let's create a new branch. Implement helper subcommands. And then I'm gonna I'm gonna git add all the new things I created. Git commit -m. Implement subcommand scaffolding phpr create. Let's create an OPR. Implement scaffolding, subcommand scaffolding, whatever. Let's have a look at this. talk, whatever. We use clap. We restructured this a little bit. We now have these, we have some colors. We run these subcommands. This is now gone. We have the run subcommand. I might just create a file for this one so that it's similar to sign, even though it doesn't really take any arguments. And then we have the sign down here. So let's do that, and then it looks complete. Oh, maybe I also implement a verify command, and then we can go back and forth. Let's do mod run. And then we do edit source subcommand run.s. We're just going to do public and run. And then we're just going to do run. Okay, let's have a look at the just file. Cargo run jrun. Okay. Jrun, yeah, whatever, jrun. Cargo run sign also still works. Cool. I think, yeah, let's just, I guess, create a verify function as well, because why not? Verify a message from an oracle. I'm going to call this verify. And then we're going to do verify.run. Verify. So verify is also going to take some things. I need to create it first. Edit source subcommand verify.s. Use super. Verify. And then message to verify. We implement the verify command in ord. I'm just going to have a look at this. Let's see, ord. Verify. See what I did there. Yeah, we have different inputs. Text, file, witness, transaction. So I think it's just going to be the message, signature, and public key. Message. Signature. Okay, so to verify, I had some tests somewhere. Oracle. Sign message with Oracle public key. So yeah, let's look at the spec. So to verify a message, we go to Oracle. So yeah, the signing algorithm that they use is BIP340, which is Schnorr with tagged hashes. Tagged hash is just a way to ensure that whenever you sign a message, nobody accidentally, if you sign something, that they don't give you, a transaction or some sort of struct that they could then use to kind of steal your outputs. It kind of takes the message and hashes it multiple times with some salt, with some extra data, so that you can't accidentally sign something, like accidentally sign a Bitcoin transaction. So that's why you have these tagged hashes, which, if you look here, is this thing over here, h equals tag hash with this tag. At least this is how I understand it. And I've implemented this in the lib. You can see here tagged hash is here. So in order to verify a message, we would have to let tagged hash equals tagged hash self.message message.asbytes. What's it called? Tag message hash. Okay. And then we have to verify this over here. Have to do this. Tagged message hash. I mean, yeah, at the moment, every command I run, I create a new Oracle. So yeah, it's kind of stupid to do it this way. But yeah, we'll figure it out. Let me just implement this, and then I'll figure out how to do this correctly. Let me turn on some lights. Okay. So I think, yeah, let's just finish the. Let's finish the. Let's finish this. Okay, so verify Schnorr, of course, does not take strings. It takes stuff that is parsed. So message, signature, public key. Maybe this Oracle public key, message, signature. Yeah, kind of like this order. Let public key equals x only pub key from string. Oh, look at this, we got this. So we do self.public key. What does this return? Well, let's signature. Signature from stir self.signature. Then we can just call these things by what they are. Expected this, yes, okay. Cool. Let's commit this. So let's just try that. Let's do cargo run sign. Hello, my name is Pythia. And then we do cargo run. We're going to create a test for this as well. We're going to do verify message. I'm very interested to see if this works. Public key. Let's see if this works. It's going to be interesting. Probably something's going to fail. I doubt this is going to work. And then the signature. Okay, it seems to have worked. So let's see if it fails. So if I now remove this A, malform signature, cool. We get, so let's add this back. It works. So let's change the message. Hello, my name is Bob. So this should fail. Signature failed verification. Cool. So it works. Cool. So now we do cargo run. You can see we have these nice little commands. We have some nice colors. We can run the oracle. We can sign a message, and we can verify a message from an oracle. Print some help. Yeah. Let's commit this. Git commit and verify command. Verify command. Subcommand. Cool. Let's have a look. Okay. Okay, so we have basic subcommands. Let's have a look at the README. So we have basic kind of command line arguments. Of course, every time we run these commands, it starts a new oracle. So I'm not persisting the private key in any way, or storing anything. So I'm thinking maybe I add either in this PR or follow-up PR, the ability... Oh. I think I accidentally killed my screen. God damn it. Okay, 1 second. Am I back? You guys hear me? See everything? Okay. I hope. I can hear and see. Perfect. Thank you. Options and configurations. So I'm kind of, yeah, maybe you should be able to configure a private key and store it. Let's write a test first. We can start the testing infrastructure. So now that we have these commands, I'm going to write some integration tests. And these tests are going to live in the test directory. Just close some things. So I'll make their tests. For that I need to also again have a look at the right cargo configuration. Tests. Auto bins. I want this as well. Bin is this thing. I have this. Bin is this thing. Yep. And then we want this test thing as well. So I'm just gonna add this here. And then we're going to edit tests lib.rs. And I'm just going to have a look. What do we do here? Tests lib. Cool. So we have a lot of stuff in here. A lot of helper functions. Oof. Should we take this command builder thing as well? I don't know if I want to spend time on this. I want to look at a different repo for a second. What do I do here? Yeah, this is a whole thing. Do I need this? I'm just gonna have a look what I'm doing here. I think I can do it with a little bit. tempter self args command standard in piped. Yeah, I don't think I'm gonna add this here. This is too much work, and it's not worth it doing it right now. On tests, I'll do this at a different date. This is not interesting for the stream, so I'm just gonna delete this. Let's run the CI. Okay, we have some tests in here that can work. So look at the PR. Cool. If anyone wants to have a look at this PR and approve it, I'm going to post it in the chat. Feel free to have a look and click approve. Command line arguments. Yeah, we have now command line arguments. I'm going to add this to the README. Rx. Push the changes. We change this. We have arguments with nice colors. We import some stuff. We remove this. We now run it all through the subcommands. Looks good to me. We have run, sign, and verify. Run, sign, and verify. So our subcommand run. Source command sign. It's all very quick and dirty. Like we would want, like these print lines are kind of ugly. So at some point we'll kind of return JSON or something instead of just printing this out. Same with this. Like this run command it's just there to have something. But this will probably be renamed to server, and then it'll run a server when we get to the server. Seems fine. This seems fine. And the verify command verifies signature. So yeah, if anyone wants to improve, a couple more seconds until this test passes. I'm going to move on to the next feature. I think my OBS stream fucked up. OBS restart stream. I think I have to restart the OBS stream. 1 second. Auto stop.